I just want to start out by saying a few words about Synaptiq. We've been around for quite a while now. When we first started out, we just did AI and machine learning consulting. It was all these fixed price projects where somebody would come and say, "Hey, we've got this data. We've got a problem. Can you help us get from the data to the solution?" And we did that for several years. Then, as things progressed, we started running into more cases where people had lots of data stored in lots of different locations, and they needed to get it unified, put in one location so that we could actually do the analytics on top of it. So we started doing more data engineering. And then on the other end of the pipeline, people were building these interfaces that would surface the information that was being extracted from the data to either internal or external users. And so we started taking on more of that as well. So we think of ourselves as intelligent products, sort of spanning the gamut from we've got a bunch of data, we got to move it around and clean it up and get it stored in a central location like a data lake or a lake house, to we're going to apply AI methodologies to it, to we're going to try and figure out how to surface that to people who can consume it in the best way possible, the most effective way possible. So here's the outline for today. I do have 10 ways. It's funny, I was joking with Sam. I was like, next time we should make it 6 ways. So we'll see. I have 10 of them, and we will see if we get to them. I'm going to start out actually talking about this thing I'm calling the data and AI value chain, because as you can see in that box at the bottom, the problem, I think, is that most companies don't have a shortage of data. They've got a lot of data. We'll talk about that in just a second. Sometimes there are some issues with can you get access to it all and is it clean enough? But we're not going to talk about that today. There's another webinar I've done on that. But often the problem is that completing the value chain is the problem, is the challenge. So I've got these 10 ways. I'm breaking it up into 4 jobs, which I'm calling operate, serve, protect, and unlock. That sounds a little bit like a Coast Guard slogan potentially. But in this case, for business, it means we're going to try and run our business better. We're going to grow and keep our customers. We'll defend the business, and we'll talk about what that means. And then having a bunch of knowledge, we're going to try and set that knowledge free and make it effectively usable by, again, either people inside or outside the company. And then I'll wrap up with a few concluding thoughts. So let's talk a little bit about the data and AI value chain. So there's all these metaphors out there, and I'm using the rocket metaphor, right? So if AI is a rocket, data is the fuel that propels it, right? So you've got this machinery sitting there, and that machinery has to grind on something, and the thing that it's going to grind on is the data that you've got. Now, I found this sort of interesting chart in a Cloudera report, and the name of it is there if you want to go look it up. It's just you give them your email address and name, and they'll let you download it. Um, so they went and surveyed a bunch of organizations of different types and said, consider the following statement. Do you think it's extremely true or very true? I have complete visibility into where 100% of my organization's data resides. It seems like it's either true or false, right? But in any event, people are just saying, yeah, like I think I agree with that thing. And you can see, for example, in telecommunications, 89% of respondents were like, yep, totally. I know where my data is. On the right-hand side in the public sector, they're like, I don't know. We got a bunch of data lying around all over the place. We don't know what's going on. I will say healthcare is surprising. I don't know what the other 13% are doing, right? So that's a little shocking. But in any event, people are like, yeah, we got a handle on our data. And again, there's a difference between knowing where it is and what it is and being able to use it. But for the purposes of this discussion, we're going to kind of think about what can we do with the data, assuming that it's in a usable format. So what is this data and AI value chain? So starts with data. Often insights come next. We've done a lot of work in the past where we've built dashboards for people. We've been doing that for a couple of clients recently, and a couple of months ago, I was in a meeting and we were showing a dashboard, and they were like, "That's great. This is super interesting. We didn't know that about the data." So insights are useful, but they don't equal decisions, right? So you can go, "That's cool. I didn't know that about my data." But you need to then sort of say, how are we going to change our behavior? What decisions are we going to make based on that? Once you make a decision, you have to put it into action, and then ultimately you need some measurable outcome. And I think as you get further to the right of this chain, you get more and more drop off in being able to handle it. So, it can break anywhere. The data's not good, the insights are unreliable. An insight doesn't mean you're actually going to do anything with it. If you make a decision, you've got to have an owner. Somebody's got to actually track, are we taking action on that decision? And then, if you're taking action, but you're not watching to see if the results are good or bad, you might as well have not taken the action in the first place. So, what I would suggest is as we go through these sort of 10 ways, as I'm going to call them. And if we don't get to all 10 of them today, that's okay because we can share the slides with you. Think about in this context, what insight is the data trying to provide? Are you trying to extract from it? What decision is being changed? After I've made that decision, what action is going to follow? And then how do I know if it was a good thing or a bad thing afterwards? Let's think about operating or running your business smarter. So, um, this is one of the most powerful things. And so, actually, if you'll look up here, I don't know if you can see my cursor or not. I've got this is way one, and then we're in the operate, run smarter. So you can kind of track across the top of the screen where we are in the talk. So, one of the most powerful things about modern AI is that it is democratizing access to the technology. So, anybody can go online and talk to Chat GPT or Claude or Gemini about any number of topics. But a remarkably useful version of that is that you can also create natural language interfaces. So I can talk to a database, for example. I can talk to a spreadsheet and I can ask questions about it. And so, some examples there are a sales leader might want to figure out which regions were missing their quota and why. Or a supply chain manager might say, look, which of our suppliers were late with their deliveries and what products were affected. And you can take that English and you can turn it into a query that goes against the underlying data. On many of these slides on the right-hand side, I'll have a statistic and there's a link there. You can click on it. There is a Gartner survey that said 50% or more of organizations are already doing this, right? So the idea is that I've got data. I don't want to have to go through an IT team to get access to it. I like people just to talk to the data. So very powerful. That's typically called conversational analytics. And the old way of doing things was I'm going to submit a ticket, I got to wait for a while, I'm going to get a report. And if I want to modify the report, then I got to go through the whole process again. And so a lot of questions just never get asked or answered. But if you use the data, then anybody that can talk, right? I can just in plain English, I can say, hey, I got a question. It's going to give me a chart. And then because the follow-ups are easy, people start actually exploring. Now, it is the case that in theory seems straightforward, but there's typically some work that has to be done. And I think often the thing to keep in mind is that it depends on what your level of scale is. So if you are a person who works at a company and you've got access to a SQL database or a bunch of spreadsheets, you can run Claude code and say, "Hey, Claude, I got questions about this data," and it will just do this for you. However, if you want to scale it and have it available to a variety of users, then you need to build some infrastructure. You're going to have MCP servers or various ways of sort of having agents talk to data. Those agents are going to have to know where the data sources are. And there's going to be some LLMs wrapped in there. So there are ways of making this happen relatively quickly. If you want to do it on small scale, you can do it in a matter of minutes. Larger scale can take a little bit more time. So what about way two, which is, can we do demand forecasting? And so, there's a McKinsey report that says that there are examples of people getting 65% fewer stockouts, right? So I'm not going to run out of things and lower forecast error when you have AI-powered demand forecasting. We actually did do a project with a restaurant group that were looking at trying to predict demand for the raw ingredients that they use by looking at really interesting data about foot traffic in areas based on cell phone pings. Energy providers do the same thing. They're trying to figure out how do I anticipate spikes so that I can plan generation capacity. So used to be the case that, and I've seen this, there's like somebody in doing demand forecasting goes, well, we've got last year's spreadsheet, and there's somebody who's been at the company for 30 years who looks at last year's spreadsheet, knows a bunch of stuff, and then just sort of makes a prediction. But the problem is that you got to keep a buffer, right? So you're going to have stock that's piled up to cover the guesswork and it ties up cash. But with data at work in this particular case, you can actually do SKU level forecasts that are refreshed weekly. So it can be a very lightweight process just in terms of the computation and you're going to have less margin for error. So instead of padding for uncertainty, you kind of plan around it, right? Now, importantly, the forecast has to arrive before the decision it's meant to change is going to be made. Okay, so now on to way three, which is a fun one that we've done some work on before, which is this notion of kind of predictive analytics, or we're trying to identify when failures are going to happen. So, for example, there might be a manufacturer that has a machine and they say, okay, we think that this bearing is going to break. So, what we'll do is during planned time, downtime, overnight or on a weekend or something like that, instead of losing a shift, then we're going to try and fix that particular machine offline. And again, there's a Deloitte report that says, you can gain significantly higher equipment uptime and actually reduce maintenance costs from predictive maintenance. So, how does predictive maintenance work? And I'll talk about an application of this in just a second that I worked on in the past. There's preventative maintenance. So you think about, hey, I got a lawnmower every year in the spring before I start mowing. I'm going to change the oil and replace the spark plugs. Nothing is indicating that that needs to happen, but it just seems like it's a good idea. Predictive maintenance happens when there are subtle signals. And so in manufacturing circumstances, it might be that there's some weird vibration that you can't hear it, but you can sense it with ultrasound. Or maybe you can kind of like have an infrared sensor that, or a temperature sensor that goes, that thing's running a little bit hot. At some point, you actually start getting audible noises, right? Like your lawnmower is making a very weird noise. I don't know what, that doesn't seem good. Or you start smelling something or it's getting real hot and then it breaks down, right? So predictive maintenance is in that sort of sweet spot in the middle where it's running, you've done the preventative maintenance, it's not obviously getting ready to fail. Let me see if I can detect whether something's going on. So I did a project a long time ago for a company that was in the amusement park business. And the rides that they had were controlled by these just binary switches. So the control system would send a signal to sort of open or close a mechanical switch. And what they did was they instrumented all that. So they had a ride that had these sort of 653 binary sensors, sort of all these switches. And the sensor goes, is that switch open or close? And they set up a data acquisition device to monitor that, generating this massive data set. And it turns out by talking to some domain experts there that if I send a signal that says, "Hey, switch, open or close," and it does this kind of clean transition, it went from open to closed. That's good behavior. But if you have this sort of chatter, which is like, okay, it's like trying to change state, but it's kind of flipping back and forth between them, that's not good. And so what we did was we said, hey, let's go through this particular kind of pipeline, which is we're looking at the sensors. We had to be relatively clever about whether we could detect a risk or not. Once a risk was detected, you had to think about how am I going to fit it into a maintenance window. So if the ride breaks, everybody gets off the ride, the maintenance people go out there, they fix it right then. But if you say this looks like it's going to fail because that sensor is getting kind of chatty or chattery in this particular case, when can I fix it? Do we have the parts? And then we need to plan the repair. So it's not enough just to be able to identify it. It has to be early enough. Is there time for me to get this into the schedule? It needs to be specific enough or reliable enough. So on the specificity side, how many false positives am I getting? How many false negatives am I getting? It's got to be the case. And in this particular predictive maintenance case, the technicians or the maintenance people, if you sent them out there twice and it wasn't about to break and they didn't look at it and go, yeah, it was good we went out there, they would just completely ignore you. And then you have to do the cost benefit analysis, right? We're going to do this maintenance. There's some risk if we don't do it, but is it really expensive? Do we have to shut something down that's going to take time for us to fix? Okay. Now let's think about kind of growing and keeping customers. So we're going to try to serve our customers a little bit more. Another type of work that we've done, or another kind of project that we've done, is to this sort of personalization. We once did a project for a company that provided training materials to other companies. So you're running a small business and your people need to do training of a variety of kinds and in terms of dealing with protected data, for example, or maybe there's some HR training that needs to happen. So this company had a bunch of training videos and they would say, hey, company, you've come to us and you've sort of looked at these videos. We think these others might be super interesting to you. And so we've also talked to a couple of companies who are doing things like personalization in media, such as the example there, where, hey, we're going to show a soccer game, football, right? And what we'd like to do is to take all the videos and actually construct a feed specifically for you. You really love this player, or you want to focus on this part of the field. What we can do is stitch together, again, a video that gets surfaced to you, which you find to be the most compelling. And there's a McKinsey report from 2021 that says, up to 40% more revenue can come from personalization at fast growing companies. So people respond to that. Now, there are lots of different kinds of personalization from sort of on the left-hand side to the right-hand side being sort of coarse to fine. Very common approach is just segmentation. So I'm going to find customers that look like you. So I'll take your demographics. What do I know about you? How much money do I think you make? Are you male or female? Where do you live? And I'll say, okay, people like you tend to appreciate this kind of content or this other kind of content. You buy one kind of thing versus another kind of thing. And what I can do then is make recommendations to you based on the segment. I can go finer grain detail and say, well, I'm going to look at you more carefully as a person. You as an individual perhaps as a member of a segment, but within that segment, I think you're going to respond to this kind of thing. Then you can actually sort of do it inside the business, which is, what's the next best thing for us to do? So inside the business, should I do a sales campaign, for example? And then finally, on the sort of more complicated side, we'll look at algorithms, many of which come from the field of reinforcement learning, of how to adapt, right? So I can look at what happens when I do a discount promotion to individuals, for example, and how do they respond to that thing. So what you're trying to do is go from, I will simply say, here's what we got. Do you want it? To we're trying to make it, we are going to talk to individuals and we're going to try and do that at scale. Now on to way number 5. Think about trying to keep the customers that you've got. So there are lots of models out there, lots of kinds of efforts for trying to say, who do we think is going to leave and why so that we can intervene. So, a subscription business might look at their at-risk accounts with a good offer weeks before renewal and not try and wait until after they've canceled. Now, I think many companies are ham-fisted about that. So I've got a couple of magazine subscriptions, and sort of 6 months before the subscription runs out, they say it's time to renew. That doesn't resonate with me because I think they don't care about me as an individual. They're just trying to fool me into thinking it's time for me to do this thing. So this sort of notion of churn, which is losing customers, used to be that you go, oh, okay, customer canceled. Now we got to try and win them back, which is really hard and very difficult. Or if I think that I've got data that's telling me which accounts are at risk weeks early with some reason, then I can try and target them and save them, right? So you're going from post-mortem, what went wrong, to try and prevent the churn from happening. Now on way 6, we're going to think about dynamic pricing. So the most obvious example of this, which I don't know how people feel about it, is surge pricing with Uber. You get out of a football game and there are 30,000 people that are trying to get home, many of them using Uber, and the price goes way up. So the idea there is that companies might want to change pricing to try and maximize a couple of things. And we'll talk about what those things are, right? How do you determine what the right price is? Those are typically based on a variety of criteria, some of which are listed here. So what's the demand? So again, when that football game gets out and you've got a thousand people that are all trying to get Ubers, demand is high at that point. Also, how many Uber drivers are there, for example? Do we have 500 of them or do we have 20? And in that case, if I've got a bunch of people looking for a scarce resource, then they're going to be willing to pay more. You also have to think about, how's the customer going to respond? So what are they going to accept? So, if you say, it's going to cost you $400 to get from the football stadium to your hotel. That's going to make me angry. It's ridiculous. And so what you want to do is you want to try to maximize value, but you don't want to sacrifice the trust of the customer. So you can do a variety of kinds of pricing intelligence. It can be based on demand. It can be based on inventory. You can do promotions to try and provide discounts, or you can do individualized pricing. And those things are sort of not equally risky. I'm sure we've all seen the Trivago commercials, or maybe you haven't, but the idea is that two people are at a hotel checkout, and one person, they're like, oh, that hotel cost you $175 last night. And the person goes, that's great. And then the next person, they say that hotel room cost you $100. And so the person who paid 175 gets angry. And so in this sort of dynamic pricing model, you have to think about the impacts that the prices are going to have on individuals, that being the sort of riskiest of the two. So again, the goal isn't always the highest price. You want to have a price that the customer is going to accept, but you want to have a long-term relationship. You want them to come back. You want to get excess inventory out. You want demand to be smooth through time. and you need to be able to justify it, right? So you don't want it to be price gouging, right? Because that's unethical and also is incredibly damaging to your reputation. All right. Okay. So now let's talk about protecting and defending the business. And I've done some work in this space as well, just in terms of fraud detection. And this is a thing that we all kind of face, I think. I get texts from my credit card company quite often that say, "Hey, I see this thing happening. Somebody's trying to charge something to your credit card. Is that thing okay?" Right? And it is the case that AI is used very commonly there. And I did a project 15 years ago in this space, and it was just straight machine learning models, not generative AI. It wasn't, the thing back then. But the idea is, can I learn normal behavior and flag anomalies? So fraud, abuse, other kinds of failures. But it's interesting, again, as with this notion of personalization, you have to balance competing outcomes. So you want to catch fraud, you want legitimate transactions to be approved, you want it to happen quickly, and you don't want people to have to get involved too much. And so I think for many of us, those false positives where the credit card company says, "Hey, we just blocked this transaction," are the most annoying. And I've, dealt with that many times. It's also interesting that once you've made a decision, or as you're making a decision, there's often a probabilistic component associated with this. And we'll see this in another one of the ways that comes up in a minute. So if it's low risk, I can go ahead and approve it. Like, I don't know, that might look a little sketchy, maybe. But the risk is low. The probability that it's fraud is kind of small. If you're uncertain about it, it might be fraud or it might not be, then I might send it for a second review. But then that impinges on the decision speed issue. Or if it's high risk, I'm going to block it, right? So you're sort of balancing these various competing outcomes that can happen, but also they have to be done in the context of how am I going to actually make a decision when I'm done. Now, at Synaptiq, we've done a tremendous amount of work in machine vision, and machine vision is often used, especially these days, as a way to have a visual inspector that just never gets tired, right? So, you can imagine that if you're sitting there looking at a conveyor belt and there are widgets flying by, and you need to try and figure out if they're defective or not, that could be very tiring and you're going to be prone to error because you're not going to be paying attention all the time. So also these models can, for example, in the example there, manufacturers could find micro defects that are invisible to the human eye. And I know, for example, that defects in concrete and other building materials often show up in heat signatures that are not sort of visibly apparent, but can be detected with certain sensors. Two projects that we did at Synaptiq was one, we built a system for central line dressing compliance. So sometimes when you go to the hospital, you get catheterized internally and you get a bandage put on it that looks just like that. Those bandages, though, those entry points into your bloodstream are very commonly infected. So, because you've got this sort of open access to the inside of your body, and you can get infections that cause lots and lots of deaths in hospitals every year. So, we looked at that particular problem from a machine vision standpoint. The idea being that you could train a model that says, here's a bunch of these central line dressings, and a doctor goes in and says, these are clean and compliant. These have particular kinds of problems, and we can enumerate the kinds of problems that they have, and then turn that into a mobile app. So, machine vision for detecting when things are going wrong in the physical world is a great application. We also did a project on computer vision for safety compliance in construction. So on the left-hand side, you see a picture there of some construction materials being either loaded or unloaded. Turns out that as I learned by working with people on this project, that's the most dangerous thing. When things are being moved around, when materials are being loaded or unloaded, that's when the majority of injuries happen. So we built a system actually quite a long time ago. It was much harder back then for doing things like saying, hey, how many workers are there in the site? Where are they? And are they wearing their personal protective equipment? So does the person have a helmet on? Do they have a high visibility vest? Also turns out that in construction sites, Sometimes the color of the helmet or the clothing tells you sort of what the role of the person is, and so being able to detect that is useful. Okay, so last two items, which are kind of unlocking value and knowledge that's in your systems. I think one of the most common applications of large language models these days is to take paperwork and turn it into data. So I did this recently myself. I went to my doctor for my annual checkup. I got some blood work done. I got a printout. Actually, I went to a portal and sort of printed out the results and I uploaded it into ChatGPT and I was like, hey, tell me what all this means. Because my doctor hadn't called me back yet. So this happens in lots of domains. Insurers might extract claim details. They'll look for missing or inconsistent information. And as before, they might take the routine cases and go like, hey, we're going to send those off. And then the ones that are look kind of weird, we're going to hand those to humans for more manual data entry. So there's a typical pipeline, which is you've got a bunch of documents. You might want to classify it according to the document type. And I'm going to talk about a project we did on that on the next slide. Extract the information, apply some validation checks, and then route it again, right? So if something looks complete and consistent, you've got high confidence, just send it on, right? And to the extent that it looks more ambiguous or unusual or high risk, you'll hand it to a human, right? And so this is a very common design pattern, which is machine's going to process a thing. There will be either rules or there will be probabilities that you can read out of models that tell you information about how you feel about the quality of what's going on inside that particular case. And then you can dispatch it into these three ways again. So we actually did do a project with a legal firm that's in the immigration space. And the problem was that we've got these very large tech companies that are hiring lots of foreign nationals. And the process of managing the paperwork for that has always been very slow and manual. So you pull together a bunch of information, you send it to the government looks at it. Often they'll send you a letter back going, "Hey, that's okay, but we don't think your argument along this line, like there's not really a need for that person. I think you could find somebody who does exactly that same that work in the United States." So it's just like back and forth, and it's all through the mail. So also the case that the people who are applying that are clients of the immigration firm uploading tons of documents. So I'm going to upload a form I filled out. I'll have a driver's license, a passport, a transcript from my undergraduate college. All those documents get uploaded. And what they did before was they would have people look at them. So, okay, this is a passport image. Check, that's been uploaded, right? So what we did was we built some machine vision models that dealt with that and did it automatically. So it would do this document classification automatically, and it would keep track of what are the things that have been uploaded and what's still needed. So it was deployed in a Databricks data lake and was put into production. And so what happened was that the attorneys who used to have to do this stuff now could just take, here's a packet. We've labeled all these things, like this is a passport photo, this is this particular form that's been filled out. Attorney could just scan it and go, yep, that looks good. Or say, nope, let's flip the label on that thing and go, right? And so they're much faster. They didn't like doing this work anyway because they weren't trained to do that. They wanted to think about more interesting, complicated legal issues. And it turns out that we co-authored and presented a couple of research papers on that work. So overall, very, very successful. And then so finally, the last thing here is LLMs looking at your data and then, sort of giving you answers about it. And so field technicians, for example, and we actually talked to a company about doing work in this particular space where it was HVAC technicians. And what happens is in HVAC tech land, this happened to us recently, our air conditioner went out. They rolled a truck, right? Which is the term for it. We're going to send a technician out. And what happens is the technician will come out, they will look at what's happening with your unit. The company that we were talking to was more in the commercial HVAC space. They'll diagnose what the problem is. And then what they'll do is they'll go, okay, do I have the part on the truck or not? If they don't, they have to roll another truck, right? So another truck has to come out with the actual part that you need. And so that's expensive. It takes time. And so what they wanted to do was to be able to do, for example, say, okay, I'm going to this particular site. It's a Train air conditioning system. It's this particular model. It's this age. Let me go dig through our historical records. What are the kinds of things that break? And so what they can do is they can say, well, it's probably going to, it could be a compressor or a capacitor or a bearing. Let's load those things onto the truck so that we only have to send one truck and not two trucks, for example. And it turns out, obviously, that that's going to make workers more productive, as cited here, but also newer staff get even more productive, right? So it kind of helps you get over that learning curve a little bit faster because you're not kind of digging through this undifferentiated mass of documentation. You're actually being served answers to questions that you have. So and again, the idea here is that you could use LLMs in a variety of ways, and some are appropriate in some circumstances, and not all. So it might be, hey, I just want to find the document. So I'm an HVAC tech, train model number 12. Give me the documents, right? Or it could be it's a train model 12 and it's making this weird clicking sound. Can you tell me what do you think it is? What do you think is actually going on there? Then it could go to say, hey, LLM, you think that's the problem. What should I do? Right? Can you help me figure out how I would go about repairing that? And then in sort of the more, electronic world, often you can start taking steps in workflows, right? So maybe what I could do is I would go ahead and draft an estimate for what it's going to cost, right? So you can sort of integrate this thing at various levels. Okay, we made it through all 10. I've just got one more slide on some concluding thoughts, and then we'll kind of go from there. So, I think the thing to take away from this is that there are a few things to think about, right? So I would start on the right-hand side of the value chain, right? So what's the decision that we want to make? What do we want to change? What do we want to make better or faster in our particular organization? Then work backwards to the data. So, I you see both kinds of reasoning happening inside companies. I think people both sort of have both in their head at the same time. We've got this data, we want to impact this decision. But I think the idea is you should start, what do we want to change? What do we want to make better? How do we measure that? And then work back and see what kind of data is going to support that. It's also the case that the data foundation is the most important part, right? So the models are increasingly a commodity. Things that we used to do with custom vision models 10 years ago, we just hand it to a large language model or a vision language model and say, solve this problem. And it goes, okay, I can do that for you, right? So the the thing that you often need to think about is your data foundation. Is it trustworthy? Is it connected? Is it governed in particular? So your data is the thing that makes your organization special because everybody's got access to these remarkably powerful models. And then finally, it's got to be adopted. And we've seen companies struggle with this before, where you go, here's a cool problem. We want to make this decision better. We want to improve it. We've got our data, which is our kind of secret sauce. We'll build a proof of concept, but then it just never gets adopted for a variety of reasons, often because you have to integrate it tightly into existing workflows because people don't like to kind of step outside and go, oh, here's a new system I'm going to use. So that value comes from adoption. So even if you've got a model that's 99% accurate, but nobody pays attention to it, it's not useful, right? So you have to think about the workflow. How's it going to be integrated, not just the particular metric?